Okay, this is our trig sheet. This is continuing now with question 1c. So we're looking for our formula. There it is there. I'll highlight that. We need to put it in the calculator, of course. You can see that this is a sine curve. It's been moved up to 28. And if we have a look at the amplitude is 10. So 28 plus 10 is 38. 28 minus 10 is 18. It's a sine curve, so it's going to start here, one cycle. So we can at least set up our y-axis for our view window, and here's our x-axis. Now if in doubt you could go to 2 pi if you don't know what to use, and have a hunt, see if you can find one cycle. However, if we use the formula we've learnt that says the new period, which is the time for one complete cycle, will equal 2 pi, the old period, divided by the coefficient of the variable, and in this case that's a pi. That's the coefficient there. We cancel those out and we can see that once again the period is 2, which allows us to write 1 there, half, 1.5 there. Okay, so putting that into the calculator now, we've got time on the x-axis, time in seconds. Maximum torque is applied to a pedal when Elizabeth pushes it down from a height of 34 to a height of 24. So 34 is going to be about there, down to a height of 24, which will be down below here somewhere. How long is maximum torque applied for each turn of the sprocket? So we're really looking for how long to cover that distance from there to there. We need that x value, and that x value there. So if we've just put the function in, we could, perhaps the best thing to use for this would be xcal. Gsolve, look for more options and choose xcal. And if you put in the first, when y equals 34, we get an x value of 0.7952. Returning to gsolve xcal, and this time we'll put in a y value of 24. We get x equals 1.1310, which will be this value here. So clearly the time in between these two, 1.1310 minus 0.7952, gives a value of 0.336 seconds. The answer to that question there. Right, now if we go back and try question 2, highlighting the formula we're going to put into our calculator, we're going to need some brackets around the pi and the t when we put it in. 1.48 minus cos bracket, pi times, and then we use our variable button and enter that into the calculator. Choosing a view window, the numbers aren't too big. You could have your y-axis between -5 and 5 if you're not sure, and your x-axis between 0 and 2 pi if you're not sure, and you could continue to answer the question. However, if we use our knowledge of transformations of trig functions, we can see that it will have moved up to 1.48. The amplitude is just 1, there's no extra number other than 1 in front of the cos there, so we'll go up to 2.48 and down to 0.48, plus 1 minus 1. But once again, if you went between -5 and 5 or 0 and 5, you'd be able to find the curve. It's a negative cosine, so it's going to come up like that, which you'll see from your calculator if you've got your axes set up right. If you haven't, you need to check your view window. Once again, I said if you're not sure, you could always use 2 pi, but using the formula we've been using. A new period, which is the time for one cycle, equals 2 pi, the old period, divided by the coefficient of the variable. And we can see it's a pi again, which gives me, once again, a new period of 2, and once again this is time in seconds, so 2 seconds. Now answering the problem, when will the bottom of the swing be first 1 metre above the ground? So 1 metre is about there. We want to know when the swing is going to be 1 metre above the ground. So you can put the line across at 1 on the calculator, or once again you could go G solve an xcal. Putting in a value y equals 1 will give you a value x equals 0.341 seconds.